Why, hello there. My name is Mr. Visca. I'm a cat owner, especially in the Caribbean. Jamaica's my favorite. And I like mathematics. Speaking of mathematics, why don't we get started? Unit 4, Lesson 2, ciao. Let's get going. All right, today's lesson, we are going to focus on series. Now, for Unit 4, Lesson 1, we did arithmetic and geometric sequences. Now we are going to shift slightly to arithmetic and geometric series. Right? Makes sense. As is the norm with some of these lessons, let's define what we're actually talking about. Okay? When we talk about a series, okay, we are just talking about the sum of a sequence of numbers. All right? So basically, we're going to take our sequence and add them up. Boom. Okay? So when we talk about series, again, we're just still talking about sequences. There's one minor difference. We're just going to add up those numbers in that list. A sequence is a list of numbers. Okay? And a series is just taking that list and adding them up. I've run out of ways to say that. I've said it 3 different ways, and I hope you understand that. Right? So what are our 2 different types of sequences? First of all, there is something called a finite sequence. Okay? That has a first and last term, so the sum can be found. In other words, we're going to use this thing called a sigma. Okay? And you can use x or n. You're going to have your starting whatever term that is. Let's call it 1. And then you're going to have your end term. Let's call it maybe 16. It'll end at the 16th term. And of some expression or function. And it's going to equal something. I can find out that sum. I can definitely get it because there's a beginning and there's an end. Right? Now, there's an infinite sequence. And that continues without end. So you really can't find the sum. At least not at this level. And we're really not going to go there, but in case this ever pops up, you can say x equals 1 equals to infinity of some function. And you can't find that sum. I mean, it doesn't stop. How can you add up something that doesn't stop? How can you catch something that doesn't stop? You cannot. Okay? So we are definitely going to be focusing on adding up finite sequences, and we are going to call them series. All right, the sum of a finite arithmetic series. Okay, there's a formula for a finite arithmetic series, and it's this below. S of n equals n times the sum of a1 plus an. An is your last term, okay, in case you didn't know it. This is your last term. This is your first term. This is obviously the number of terms. And you just divide it by 2. All right? This on the final really isn't a big thing to figure out. All right? Let's face it. If you're on the final and they have a list of numbers, you can just keep on adding them together in the calculator. Okay? Same thing with geometric series. As long as you know the whole sequence, if you know every number in the sequence, you can just keep on adding them. Okay? But this one is not that common in the final. Watch. This year it'll be on the final. But in years past, this is not common. This one is a lot more common to be on the final. Not that it's going to be in like 5 different questions, but if there was one question that were to come up on a final with series, it would probably be a geometric series. And this one happens to be in the reference sheet for the final. Okay? Remember, now that we're in Common Core, the reference sheet for the final is the same one you get for Algebra 1, Geometry, and Algebra 2. It's the same sheet for all 3 of those math final exams. And this happens to be on. So, what do these things mean? A1 is obviously your first term. N, that's your number of terms, right? And R. What is R? R is your, it's not like a rate like 3%. This is your common ratio. Remember, okay? Remember, for every geometric sequence, we have a common ratio. We have a common number that's multiplied to get to the next number. That's your common ratio, okay? And that's what R represents. And we will use some of these. And again, this is the one that you want to get comfortable with. Now, as a little snippet, we can use the calculator to add up or find the sum of a sequence, okay? If I press, and I will show you this in 1 second, the math button, then press 0, okay? That will give you the summation, which is that sigma I was talking about. Okay, it'll look like this. It'll put some variable here. We use x in the calculator. Equals your starting position, your ending term, and then you put in some function that you want to take the sum. All right. So let me do this. I don't really do this that often, where because I think this is a computer screen or a phone you're looking at. I would assume that looking at the calculator screen is enough, but I'll walk you up to use. If I turn this on, no. If I hit math and then 0, there you go. I can type anything in the summation form. So it is basically the same thing that we have right here. Okay? And that's nice. It's a huge help. All right, we've done a lot of explanation. Now let's actually start using it, because I've said this on multiple occasions, on multiple videos. The explanations are fine, but it's the actual doing that ties everything together. And if you can understand the process and the usage of these and actually doing the math, you'll be okay. So let's dive right into that part right now. So sigma notation, you've heard me say sigma, okay, summation. As this thing is, it's a Greek letter sigma, all right? You can use the Greek letter sigma to indicate a sum. Use limits to tell how many terms are being added, all right? Now, let me just show you what that means. Because when I teach calculus 2, when I start to think of limits, I totally go into a different area in my mind when I think of limits. But example 1 says, express the sum of the arithmetic sequence below using sigma notation. All right. First of all, my n is the number term. This is the first term, the second term, third, fourth, fifth, and sixth term. I had 6 terms, okay? So what are the 5, the 8, the 11, whatever? Those are the elements. So this is a of 1, a of 2, and so forth until I get to a of 6. Now, if you had a calculator, and this were a final question, which is a little bit easy for a final question, I don't think it would look like this. I hope you know you can just add those all up and get it. Okay? But I'm going to show you something easy with the sigma first, and, we'll go from that. So in order to use sigma, I use my variable. I can use n, but in the calculator, it's always x. So that's why sometimes I put an x here. It doesn't matter. N, x, whatever. Equals. I'm going to start at 1. I'm going to go to my 6th term. That's where I'm stopping up here. The thing is, what expression goes here? How do I know what to put up there? Well, I'm going to come up with the expression for the arithmetic sequence. Okay, I'm going to come up with the explicit formula for the arithmetic sequence. Remember, in order to find that, my equation equals my first term plus n minus 1. Yeah, I'll be okay. It is n minus 1 times d. All right? Let's recall that a to the 1, or a to whole subscript 1, I guess, This is my first term, which happens to be 5. Okay? I always leave this n minus 1. N is the variable I'm using. So do you remember what d is? D is my common difference. Okay? So let's do this. A to the n equals, my first term is 5 plus n minus 1, my common difference. Okay? My common difference is that common number that I'm adding to each term to get to the next one. So, how do I get the 5 to 8? I add 3. 8 to 11, I add 3, and so forth. So my common difference is 3. I can put this right here in for my expression. But you should be able to simplify this. So let's go ahead and simplify this. If I distribute my 3, I get 5 plus 3 and minus 3. These two combine, so I end up with 3 and plus 2. I'm going to use this. I'm going to put 3 and plus 2. This right here is exactly what I'm going to put in the calculator when I hit math 0. And I'm going to get an answer. Okay? So let's go back to our calculator. Turn this on. Is that still on the summation? Come on. There it is. Okay, let's clear this out. Let's hit math. And I said it's math 0, right? I hit the math. There you go. So if I scroll down, I just want to show you what it looks like. I don't think it has the sigma term. It actually says summation. Well, it does. It has summation and the sigma term right here. Okay. So I could just press 0. I just want to show you what that is. Okay. And you'll notice on the button that I press for the variable, not only does it have my x, but it also has n. You don't have to hit any special button to get the n there. Just press that. There's your x. I'm going to start at 1. I'm going to go up and end at 6. And I'm going to use my expression 3n plus 2. Now we're using x in the calculator, so that's fine. 3x plus 2. This is going to add everything up for us, and we should get 75. Absolutely 100%. That's the right answer. You see how that summation really saves us in a lot of work. That's the answer. 75. Okay, find the sum of the first 25 terms in the sequence 5, 9, 13, 17. Now, if I go back to example 1, this right here would have been easy to just put in the calculator. 5 plus 8 plus 11 plus 14 plus 17 plus 20. You would get 75. But now let's go here. Now I would have to do 5, 9, 13, 17. That's only 4 terms. I'd have to find the next 21 terms after that and add them all up. Could I do it? Yes, I could. Have I done it before? When I was in a situation in a test and I forgot how to do summation, you are sure as heck that I wrote down every one of those 25 numbers and added them up in the calculator because I wanted to get as many points as I possibly could because, that's the way my mind works. I am stubborn. I'd rather get it right and spend more time than be wrong. That's just me. We are going to apply summation here. So in order to do summation, x equals the starting term. I need to figure out where it ends, and I need an expression. All right. So my first term, yep, this is off again. I'm going to put up 5, 2, 3, and 2. All right, give me a moment and let me calibrate. Oh, that's off. I should have you guys lock me calibrate. I wonder if it'll record. Let's try. I got to do this all the freaking time. There. I touch the middle with a marker, right in the middle of that little X, every time this is off. And there have been times that I've been doing videos. It has just frustrated me because I have to do it 3 or 4 times. All right, let's see. Oh, that's off again. Now it's too high. All right, well, let's do it one more time. The frustration, it's nice to have technology. It just sucks when the technology doesn't work. So let's try this one more time. Okay, better. Okay, that is spot on. All right, back to math. First 25 terms. My first term is 5. So again, A to N equals 5. Now, is this geometric or arithmetic? How do I get from 5 to 9? Well, I got to add 4. How do I get from 9 to 13? I add 4. Oh, perfect. Perfect. My common difference is 4. That is definitely arithmetic, which means I'm going to add n plus 1 and multiply that times my common difference, which is 4. All right? Let's distribute and simplify. 5 plus 4n plus 4. 4n. 5 and 4 is 9. That is the explicit formula to get any individual term, and that is exactly what it's going to go into for my expression, into my summation. So the last thing we need is, where do I end? 25 terms. They want the first 25 terms. I start at 1 and go all the way to 25. This is what I'm putting in the calculator. Because we now know how to use the calculator, and it's easy. Okay? No, I think that's overkill. I don't think we need this. All right, so let's go math 0, and we'll put from when x is 1 all the way to 25. And I am going to, yeah, that's wrong, isn't it? That should be minus 1 here. Minus 1, which means this becomes minus 4, which means this becomes a 1. Wow, so it's 4 and plus 1. Ooh, something didn't feel right there. And I went back to check my work. Good thing I did. I'm like, there's too many pluses. I'm like, what the heck's going on? Plus and plus, and my mind wouldn't go. So I'm going to 4x, and it's plus 1. Okay, and when I hit enter, I get 1,325, and that's exactly what I should get, 1,325. That equals 1,325. Bam. So if you were doing this, and you were following this video, and you're like, well, now I'm lost. I thought I understood things, but now there was a plus here. What's going on? No, that should have been a minus. And a lot of people will be like, I thought so. When I teach in class, I make a mistake with that, and I go back and catch it. Kids will say, I thought that was the case, Visca. And my response is, well, then why aren't you saying something? Say anything. Of course, when you're a teenager, you don't like to say something to be wrong in front of people. You assume that I'm right all the time, which, thank you very much. Most of the time I am, except when I'm at home, in which case I'm always wrong, and my wife is always right. That's the rule for a happy man. Anyways, yeah, say something. I know you can't say something. You know what I'm saying. When you're in class, say something. And if you were wrong, when you say something, well, now you'll know why you're wrong. You'll still learn. And that's the big thing. All right? So, 1,325. Let's go. Looks like we have a geometric series this time. Find the sum of the first 8 terms of a sequence whose first term is 3 and whose common ratio is 4. Okay, so A, oh my God, it's off again. A to the 1 is 3. My common ratio, it is, it's off. Okay, well, you know what? I'm just going to you guys watch every time I gotta do this. Welcome, good wife. I always joke around in my 3rd period class. And I'm like, man, one of these days I'm going to throw a chair into this board. And, you know, I've got kids in there that they're smart. And they'll try to act me on and say, you won't do it. Stop. I look at them like, no, I laugh. Because I know what they're doing, and so do they. They're good guys. Anyways, find the sum of the first 8 terms, all right? That means if I start my summation where x is 1, I'm going to 8. I just need the expression. So in order to find the equation, or the explicit equation for a geometric series, I start my first term, I multiply that times my common ratio, Okay, hold on. So my first term is, yep, that's off again. Look at that, 3. My common ratio is 4. And then do I raise that to the n or to the n minus 1? I think it is to the n minus 1. And I would be correct. So, n minus 1. Okay, so my expression is right here. This is what's going in. And the beautiful part is I don't have to simplify this. I don't have to simplify this like I do in arithmetic sequence or formula or equation, because there's nothing to simplify. I literally put 3 times 4. And in here, because I'm using x in the calculator, I say x minus 1. And that would kind of be a lot of work, but the good thing for us is we have math 0, and we have a calculator to do all that monotonous, boring work, okay? Okay, from 1 to 8, I'm going to do 3 times 4. I'm going to raise my 4 after I do a parenthesis to an x minus 1. I'm going to hit enter. 65,535. That would be correct. 65,535. That, my friends, is the absolute right answer. All right, number 4. Write the series shown below in summation form and find the value of the series. All right. Well, 6 to 12, you either add 6 or multiply times 2. 12 to 24, you multiply times 2. So it is a geometric series. My common ratio is 2. My first term is 6. All right. So let's figure out an expression that we would use a summation for. Okay. I've got the summation of, all right, well, a to the n equals my first term, 6, times my common ratio, the n minus 1. Okay, n being the number of terms. So I'm going to use 6 times 2, n minus 1. I'm going to start when n is 1. Oh boy, how many terms here? I can keep doubling 24 and figure out how many times I could, or excuse me, I can keep doubling. I guess I would start at 6. And then when I get to 24, I keep on doubling to figure out how many times I need to double that, or multiply times 2. That would be my final term. Well, let's use some math here. And we haven't done this yet in class. I'm just going to show you real quick. And in this unit, we're going to deal with this. But let me give you a sneak peek of that. My last term is 768, right? This equation tells me I can find any one term. Okay? If I know 768, I make that equal 6 times 2 to the n minus 1. All right? So n would be the number term that 768 is. Okay? The first thing I'm going to do is I'm going to divide by 6. And I believe that ends up giving me 128. So here's the problem. I can't divide by 2. 2 is a base. All right? We're going to use something called same base. And just follow me here with this. You don't have to understand it. We have a whole lesson coming up on this. All right? 128 is 2 to the 7th. 2 to the n minus 1. If the bases are the same, okay, the exponents have to be the same. In other words, 2 to the 7th only equals 2 to the 7th. This here has to be 7 for them to be equal. Okay? So I just say if 7 equals n minus 1, well, I add 1 to both sides, 8. That means 768 is the 8th term. Okay, that's what that n is in my equation term. So I come all the way back up here and I say, okay, this is actually the 8th term. So I start at 1 and I end at 8. That was a little bit of a curveball for you guys. I like the problem, but it just involves something that we haven't done yet. Okay, this right here is kind of just common sense. If the bases are the same, the exponents have to be the same. All right? And we'll get there. Don't worry. There's a lesson on that. So, all right, well, let's just put this in our calculator and figure it out. Okay, turn this on. Math 0. How I love thee. When x equals 1, all the way to 1 is 8 of 6 times 2 raised to the x minus 1. I hit enter, and I get 1,530. And that is exactly what you should get. Let's call that 1,530. And we are all good to go. Now, I could have used that formula. Where is it? I could have used this formula right here. But we're going to have problems coming up that I can show you how to use this formula. Okay? But I could have definitely used this instead of doing the series. This is the formula for a geometric series. We could have just plugged our values into here and done that. We will do that coming up. I just want to show you some uses of summation first. And we did that, we did this, and we are now ready. Okay? There are 30 rows of seats in an arena. This is example 5. The first row is 10 seats, and each row increases by 3 seats. That is an arithmetic sequence. All right? So they're telling us, or they're asking us, how many seats are in the last row? Well, I can't do anything until I come up with an equation. First row has 10 seats. A of 1 is 10. Increases by 3. My common difference is 3. All right? So A to the n equals 10 plus, that is n minus 1, times my common difference, which is 3. I can find any A to the n. I can find any output if I know n value, which number term. If there are 30 rows of seats, and they want to figure out how many seats are in the last row is 30. So n is 30. Okay, they want to figure out how many seats are in that row, if that makes sense. So how many seats would there be if 10? Yeah, that's plus. Yeah. Plus 30 is the last element, minus 1 times 3. Okay, and if I do that math correctly, it's 29 times 3, it's 27, 31. I should end up with 97. Okay, so there are 97 seats in the last row. So how many seats are there in all? Okay, summation. Summation. Starting at the first row, going all the way to the 30th row, and without simplifying, I'm going to go ahead and use this. This is my expression right here. I'm going to say 10 plus n minus 1 times 3. Because it will still work. Even though it's not simplified, it'll still work. Let's go ahead and try that. Okay? So, math 0 for when x is 1 to 30. Okay? And we put in 10 plus parentheses x minus 1 parentheses times my common difference, which is 3. I hit enter. 1,605 seats in all when I add up all the rows. That venue can hold 1,605 people. Number 6, example 6, let's talk money. A person places a penny in a piggy bank on the first day of the month, 2 pennies on the second day of the month, 4 pennies on the third day, and so forth. Will this person be a millionaire at the end of the 31st day of the month? Justify your answer. Justification means show your math. All right. So first of all, I start with 1. Okay. Then I go to 2. Then I go to 4. It looks like it's doubling or multiplying by 2 every day. So I have a geometric sequence. I take my first term, common ratio to the n minus 1. The first term is 0.01. It's a penny times my common ratio, which is 2, because I'm doubling. to the n minus 1. This is what I'm putting in my summation. I'm going to start on day 1 and go straight through to day 31. Up 0.01 times 2 to x minus 1. Yes, I'm switching between n to x because in the calculator it puts an x. Okay, it doesn't matter. Let's see if he's going to be a millionaire. Math. 0 from x is 1 to 31.01 times 2 raised to x minus 1. You know, a lot of times I'm staring at the calculator face I'm typing these in, and if something's messed up, I won't even know it until I look up. Oh, yeah. Oh, man, the boys are going there. What? A person, this person. 21,474,836.47. Don't forget to answer the question. Will this person be a millionaire? Yes. That's the answer. This is your justification. Good job. Good job. All right, let's see some examples of Regents questions around the geometric series. Okay, and on the reference sheet, this is what you're going to have. Okay, this S of n equals your first term, which is a to the 1, times 1 minus r raised to the n, all over 1 minus r. Keep in mind that r is your common ratio. It's not some sort of percentage rate. It is a common ratio. So, let's take a look at example 1. Jake wants to buy a car and hopes to save at least $5,000 for a down payment. The table below summarizes the amount of money he plans to save each week. All right, let's look at this. Based on the plan, which expression should he use to determine how much he saves annually? Remember, this is like your x and this is your y. In other words, this is your n and your dollars is a to x. All right, so we need, okay, we need the first term. First term. My first term is 2. N just tells you it's the first term. N is the number term you have. The actual term is the y value, the a to n. Okay? So, in other words, this is when n equals 1. This is a to 1. That's what they want here, a to 1. Okay? So, I've got 2 times. That's always 1 minus. What is my common ratio? How do I get from 2 to 5? How do I get from 5 to 12 and a half? How do I get from 12 and a half to 31.25? If I take 2 terms and just divide them, okay? If I take my bigger term, which is 5, and divide it by 2, that will give me how I get there through multiplication. And let me say that one more time. If I take 2 terms in a row, and I take the bigger, well, I guess the further down the line, okay, my third term and divide it by my second term, okay? Or if I take my second term and divide it by my first term. If I take 2 terms in a row, I take my third term and divide it by my second term. So there's 12.5 divided by 5. I'll get that. If I take my second term and divide it by my first term, I'll get 2.5. That might not be obvious to you. That might not be like, oh, okay, my common ratio is 3 because I'm multiplying times 3. That is definitely not a whole number for your common ratio. But that's fine because we know an easy way to do it. I could take term 4 and divide it by term 3, and I should still get 2.5. Okay? So my R, yep, that's okay, is 2.5. All over, well, 1 minus R. 1 minus 2.5. All right? Now, anyway. So how do we do this here? What do we got next? Let's take a look. And the final is infamous for doing this. Okay, well, the bottom should be 1 minus 2.5. Well, they all have a bottom of 1 minus 2.5, so that doesn't help us out. For the tops, you notice how there's no parentheses? Look what they do. They distribute this 2 here. So the top should have 2 times 1, which is 2, minus I've got the second distribution here. It's 2 times 2.5. 2 times 2.5 to the n. Be careful. I can't multiply 2 times 2.5 because in order PEMDAS, exponent should happen first. So I can't combine those. I gotta leave it like that. And look what they do. It's kind of a nonsense. It is 1. That's your answer. You know it should be to the n. It's right in the reference sheet. It's not to the n minus 1, it's to the n. Okay, and the answer is 1. Last problem, number 7. Alexa earns $33,000 in her first year of teaching and earns a 4% increase in successive year. Write a geometric series formula for Alexa's total earnings over n years. Use this formula to find Alexa's total earnings for her first 15 years. Okay, to the nearest set. My first term times 1 minus r to the n all over 1 minus r. My first term, which is the first, I guess, amount she earned, 33,000. 1 minus r. Now r, first of all, we can't put percents. We can't put percents into equations. We've got to turn it decimal. My r, when I say it's not a rate, my r is not 0.04. It increases by 0.04, which means if I want to take 33,000, it's 1, isn't it growth? Isn't it plus or minus our rate? Our growth is 0.04. So 1.04, if I add these, that's how I get to the next term. I don't multiply 33,000 by 0.4. That would decrease it. So I got to add 0.04 to 1 and then multiply it. So my rate is 1.04 to the n all over 1 minus my, I guess, common ratio. I said rate before. This right here. 1.04. Okay, that's the trick. That's where it's going to throw everybody off. Okay, now they want to know, this is an equation. Here's the formula. They want to know in year 15, how much has she earned altogether? Okay, how much has she earned altogether? So all I'm going to do is throw a 15 in. Okay, I have 33,000 times 1 minus 1.04 to 15. That's inside the parentheses. All over 1 minus 1.04. And literally just put that in the calculator and hit enter. All right? So, let's turn this bad boy on. Anytime there's a fraction, on. I like to hit alpha y equals enter and get my fraction. I'm going to start this exactly as it is. 33,000 times 1 minus 1.04, raise the 15, pop off, and there is my numerator, all over 1 minus 1 point, yep, 1.04. Don't need it for friends. And this teacher has earned in the first 15 years a total of $660,778. It's money. That will save $39. Do they want that to the nearest dollar? What do they tell us? The nearest cent. $660,778.39. The one thing I want to discuss before we end this video, because this is the last problem, I don't want to pay out. Okay. If we just use 0.4, what should we earn? 33,000? That's 3,300. If I just multiply that times 0.4, 0.04, I should say, that means the next year she would make $1,300. 0.4 is decreasing. If this number in here was 0.4, that would definitely, it's less than 1, it's decreasing, okay? I need to take the 33,000 and then add 4% to it. The 1, make sure you keep the 33,000. Then the 0.04, because this value is bigger than 1, it's 1.04, is what adds 4% to what you originally started. Again, a geometric series, think of it as an exponential equation, right? If we have a, b to the x, which we're gonna do this coming up, so this will make more sense when we move forward in this unit. This is where I start with my initial amount, 33,000. I mean, from algebra 1, this is 1 plus or minus your rate. That's an exponential. That's exactly what we need to use for geometric series. All right? In this case, it's growth because you keep on making more money. It's 1 plus your rate. What's your rate? 0.04. So 1 plus 0.04 is 1.04. So if we had an actual geometric series for this woman's wage, it would start with 33,000, and my common ratio would be 1.04, which means to get here, I multiply times 1.04, whatever this is. To get to here, I multiply times 1.04 and so forth, not 0.04. This is what the test does to you. Just make sure you understand. I'll see you later.